Besides creating and storing digital drawings of pottery, the LAP application also has some analytical functions that can be applied to our data. They're accessible via the browser interface. And the first one we will look at is the regenerate drawings function. So let's say I would like to change the color of the profile, but not only for one drawing, but for all of the drawings in my database. So I can go to settings and change the fill color here, gray. And now either select all entries or just select none. This will automatically apply the whole data set, and click regenerate drawings. So I'll take a bit. And now all the drawings have been regenerated with the different color setting, and in this way I could change the scale bar or any other setting that applies to all drawings, not just individual drawings. Another function, let's say more analytical one, is the calculation of the estimated vessel equivalent, which in this case it's a useful tool to estimate the percentage of the preserved part of the vessel. So how much of the vessel has been preserved, and it's calculated using the arc that has been captured when measuring the diameter. Maybe you remember when we measure the diameter, we capture an arc on the fragment, and then the whole circumference is calculated based on that arc, and then we can measure the ratio between the length of the arc and the reconstructed full circumference of the vessel, and this can be seen as the percentage of the preserved vessel. So this is the equivalent of a Eve index. So this is another case where it's good to have all the associated information with the drawing preserved, not just the one that we actually use to recreate the drawing. So I can either select individual entries or just leave everything unselected and click Eve. Here I can select the descriptor which will be used to store the index and the standard deviation of the calculation, this is calculated in case I have captured more than one arc, which is usually the case, and this will be stored as individual descriptors for each object, for each sample. So I click OK, and now the Eve values are not immediately displayed here in the browser interface, but I can, if I open the deposit database, I can see they are here under there as descriptors of the sample class. If I just open the sample class, look at the descriptors for the individual samples, the Eve is calculated here. Since for this sample database I only have one arc captured for each sample, the standard deviation is 0. So if I wanted to see this also in the browser interface, I can just add the Eve descriptor here in the list of the selected descriptors. So if I type in sample.eve here, the Eve will be listed here. Another value we can calculate is the length along the profile. So this would be the length of an imaginary axis going through the center of the profile. So even with more complex shapes, let's say this one, the length wouldn't be just a straight line, but along the profile. This is useful again to estimate or to find or to filter out profiles or fragments which have a sufficient length of the profile preserved for to select them for further analytical purposes. So let's have a look how the function works. I can deselect all entries so that it's calculated for every single entry. Click the calculate length tool. Again, I can choose the name of the descriptor that will be used to store the length, to calculate it, and again I can look it up in the deposit interface. It has appeared here as a descriptor of the sample. You can see the length, it's in millimeters of the profile. So I could use this to filter samples based on their length. So let's say I add sample dot length here and add a where clause where sample length is greater than, let's say, 50 millimeters. And now it filtered out only those samples that are longer than 50 millimeters. So the last function I would like to show you is the calculation of the average thickness of the profile. So this would be the thickness in millimeters measured along the axis and then averaged for the whole profile, which is again useful to filter out profiles or samples that have certain properties. So I can again deselect all the entries and calculate thickness, select the descriptor here, click OK, and here we have now the thickness, the average thickness in millimeters of the profiles.